So we'll talk about one more way of finding the volume of solids, and this is when we know what the cross sections are. And I guess we've always known what cross sections are, but they've just been discs or washers. So here we're going to look at we can have different shapes, many different shapes in addition to the circles and washers. So if we have a sheet of paper, and I'm just going to try to help you visualize what's happening. So we have a sheet of paper. Is it possible with this square sheet of paper to make a solid cube made out of sheets of paper? So if we have one sheet of paper, even though it's very thin, if we just kept adding up many sheets of paper until the number of sheets equals the other dimensions, then we would have a cube. And so we're just adding up many sheets of paper to make a solid cube of paper. And then we have a cube, and if we just kept adding on, we'd have a rectangular prism. So the shape of this is called the cross section. If we just keep adding them up, we create a solid. This is solid too, it's just very thin, so if we stack them up, we have a bigger solid shape. And then could we make a sphere with cross sections? And if we just let's make a cylinder with cross sections, and that would be if we started with a circular piece of paper, and then we just kept adding these circles together. If we added many sheets of paper together, then we create a cylinder. So then the shapes that we can make are just determined by whatever the cross section is. So if we had a triangular piece of paper and we just kept adding these sheets of paper together, then we would create a solid. So to find the volume of any of these solids, all we do is we find the area of one of the sheets or cross sections multiplied by dx, which is the thickness. So if we have a sheet of paper and it has a thickness of the differential of x, dx, now we can find the volume of that sheet, and then we just integrate, and that adds up an infinite number of these cross sections. Find the volume of the solid with square cross sections perpendicular to the x-axis and base region bounded by y equals 0 and y equals negative x squared plus 1. So these have to be pretty wordy, and we just want to recognize the vocabulary used in these types of problems, but I'll cut down the length of the question on the next ones. But we need to determine the base region, and then out of that base region will come cross sections. So let's start by drawing the base region. Parabola shifted up and reflected down. Shifted up reflected down, also bounded by y equals 0. So the cross sections are going to be stacked coming out of the page. If we took this square and fit it into this region, that's how the cross sections will be oriented. So we're looking down on it. There's a cross section. It has a thickness of a width of dx, and then so that's the square paper coming out of the, or square cross section coming out of the paper. If we look at it like this, so here's the x-axis, there's the parabola, and then we can see that whatever this length is, that'll be the height. Then we have another one with a longer base. Okay, and you don't have to be able to draw it, but just so that you can see how the squares are adding together. So let's start with the process of finding the area of a cross section. And the cross section would be, if we have this, there's the cross section, we need the area of that. So the area, since it's a square, we just need to find the base and then square it, because the base is equal to the height. The base is top minus bottom, so that's going to be, we have base times height. The base is top, which is this, minus the bottom. The bottom is y equals 0. The top of this line, the top of this is the parabola. The bottom of this is y equals 0. So we go top minus bottom. And the height is the same thing because it's a square. Let's do volume of a cross section. And I'll simplify this. We don't need to write the 0. We just have negative x squared plus 1. This is times itself, so it's squared. And then the volume comes from multiplying it by the differential of x. And then by integrating, we're adding up an infinite number of these. And in the beginning, I forgot to find the interval. So let's add that step in the beginning, and that is determined by this statement, perpendicular to the x-axis. So if we have a cross-section perpendicular to the x-axis, we know we're going to have a dx. And we have a vertical rectangle, vertical cross-section, and that means we need an x interval. And the parabola intersects the y-axis from -1 at -1 and 1, so we'll go from -1 to 1. And using a calculator, we should get that. So without writing so much, we know we have square cross sections. The base region is this, and also the rectangle or the cross sections will be perpendicular to the x-axis. So pause the video and try this one. at y equals 4. And then we have a parabola so there's the region. We need to find, we know that we're going to use a vertical rectangle, and we have a dx, so that means we need an x interval. We can see the x interval goes from -2 to 2. The squares are going to come out of the paper. If it helps to visualize like this, we have square here, get a little sloppy. So we have the squares coming out of the paper. We need the area of a cross section, and the cross section is a square. So we have the parabola, and the other part of the boundary, we have a square. We need to find the length of this, which is top minus bottom. 4 minus x squared. Looking at this, we have the top is 4, the bottom is x squared. So it's going to be base times height. Because it's a square, it's not always base times height for every shape. The base, the length of the base is the length of this line, which is 4 minus x squared. And since it's a square, the height is the same thing. We can do the volume of a cross section, and the volume is just this times dx, and then the volume of infinite cross sections is the integral from -2 to 2, 4 minus x squared squared dx. We just integrate that, and we should get 34.13. All right. We can modify the shape of the cross section, or have a different shape of the cross section. So the cross section is a rectangle. Okay, so this is just going to be used when we multiply the height up here. So with a square, we find the base. Well, we're still going to need to find the base in this one, but the height is going to be 3x minus 1. So pause the video and try this one. X squared and 4. Well, that's the same region that we just had. We know it goes from -2 to 2, and for all the problems that we do today, they will always be, the cross sections are perpendicular to the x-axis. So we know we have a differential of x, and we have the x interval -2 to 2. So the solid will look similar to the square we just did. It'll just have, the height will be different. So let's look at, if we have this, we're going to have a base, and then the height will be determined by 3x minus 1. And the base will be the same, 4 minus x squared. Okay, the area of a cross-section. Here's a cross-section. The area is base times height. The base of the rectangle, the length of the base is 4 minus x squared. That's top minus bottom, 4 minus x squared. And the height is 3x minus 1, because that was given. The volume of a cross-section is just the area times the differential of x, and then the volume of the solid. The volume of infinite cross-sections, if we integrate from -2 to 2, and using a calculator, you know what, that should just be equal 6.6, and since I put that bar on it, it should be up here just equal, not approximately, not approximate, and that would mean in the beginning we should, since I put that bar, should be equal. Now we follow all the same steps, we just have a different area. When we calculate the area of a cross-section, it'll just have a different formula. Here we have the base is cosine, and then x squared. So if we see x squared going like this, cosine going like that, there's the region. The cross-sections are perpendicular to the x-axis, so the cross-section will go like that. We have a dx, and we need the x-interval. The x-interval will be the intersection of the two lines. So on a calculator, we will graph cosine and x squared and find their intersections. The intersections are -0.824132 and positive 0.824132. So the same thing is happening here. If we have the cosine and parabola, then we have cross sections that are semicircles. So when we find the area of cross-section, the area of a cross-section, the cross-section we have the base region, and that will be the diameter of the semicircle. So we have, we need half of the area of a circle. 1/2 area of the circle, so that's 1/2 pi r squared. We're using a semicircle, so it's half of the area of a circle. And we also need to be careful because we have the diameter we need half the diameter to use the radius. So we have 1/2 pi. We'll need the radius squared. The radius is half the diameter. The diameter is top minus bottom. So here's the diameter of the semicircle, which would be this distance on the graph, and that'll be top, which is cosine, minus bottom, which is x squared. Cosine minus x squared. And that we need to take half of that, because top minus bottom is the diameter. We need the radius, so it's diameter divided by 2 squared. Radius squared. Then if we simplify that, we're going to square the 2. It's a 4 times 2 is 1/8. Pi stays the same, and then we have cosine minus x squared squared. So that's the area of a cross section. Let's do volume of a cross section. Pi over 8 cosine minus x squared squared dx. Also look at how this would be the same as if we had square cross sections, top minus bottom squared. So for semicircles, we just multiplied by pi over 8, and that gives us the semicircular cross section. Then if we go the volume of the solid, we integrate from negative 0.824132, positive 0.824132, pi over 8, cosine x minus x squared squared. And you don't want to round these numbers because that'll make the answer less accurate. You can round the answer, and we'll say that that is about 3.43. Alright, and so this will be the last example. We went over squares, rectangles, and semicircles, but then there are also the other common cross-section is a triangle, and you can have all the different types of triangles. Okay, so pause the video and try this one. X squared and y equals 1. We know that they intersect at -1 and 1. The cross sections are perpendicular to the x-axis, so we have dx, and we'll have the x interval from -1 to 1. So if we have the region like that, we'll have semicircles. And we need the area of a cross section. The area is 1/2 the area of a circle. That's 1/2 pi r squared. Then to find the radius, we have to do diameter divided by 2, and the diameter of the semicircle is top minus bottom. That's 1 minus x squared. So then if we square that, that takes us to the pi over 8, 1 minus x squared squared. Area of a cross section. Let's do the volume of a cross section. From -1 to 1, pi over 8, 1 minus x squared squared dx. Oops. So that's not the volume of a cross-section, that's the volume of the whole solid. The volume of the cross-section will just be, if we remove that, there's the volume of the cross-section, and then we'll do the volume of the solid is with the integral. And we should get 2 pi over 15. All right, we'll stop there.